there's two.
Exactly. And some of you might think they look scary, but the reality is these problems are actually easier than the other ones. So let's look, this is, no, I'm in 4.7, this is number 2. I'm doing this problem right here. It is very, very scary. My calculator could do this problem, but the directions say find the exact value. And anytime that word exact is there, that means we're doing it by hand, okay? So we're gonna do this problem by hand. So I'm not gonna do this anymore, I'm gonna do this for this first problem, but I'm gonna write out what this says. This literally says, find the sine of the angle whose tangent is 3/4. Colleen, will you pay attention here for a second?
Oh, yeah.
Thank you. All right, so we're gonna find the sine of the angle whose tangent is 3/4. So the first thing I want you to do is to cover this up and draw a picture of that angle. Now, that's a positive number, so I'm going to draw it in quadrant 1, right? All my positives are in 1. I'm ignoring this under my hand, I'm just doing this. If the tangent is 3/4, then tell me about the sides of my triangle. Here's your angle. Tell me about what's 3, what's 4. Opposites 3, adjacents 4. Now, we saw some triangles that kind of looked like this back in another section. What did we always do when we had 2 of the sides? What did we always do? Pythagorean theorem to find the third side. So let's do that. So this is C, that's my hypotenuse. 3 squared plus 4 squared is C squared. So 9 plus 16 is C squared. 25 is C squared. So C is 5. Okay? Now, the question is, okay, there's the angle. There's a picture of this. I want to know what the sine is. Well, that's easy. What's the sine of that picture right there? 3/5. The answer to the question is 3/5. We drew a picture of this angle. This means the angle whose tangent is 3/4. We drew a picture of that. And then we simply figured out what the sine is. Opposite over hypotenuse. All right, so now what does the next one say? I'm not going to write it out in words, but I'll say it. Find the cosine of the angle whose sine is 5/13. Okay, so cover this up and draw that picture. Okay? We're drawing that picture right there. So, I'm going to draw quadrant 1. How do I know it's in quadrant 1?
Positive.
Positive, right? And here's my angle, so what's 5 and what's 13? 13 is the hypotenuse, 5 is the opposite. So what do? Find the third side, the missing side, which I'll call B. You can call it A. I don't care, it's A or B, doesn't matter. So B squared plus 5 squared is 13 squared. So B squared plus 25 is 169. B squared is 144. What's B? 12. Now, they're not always going to work out so nice. Remember before we got radicals sometimes? We could get radicals here. It's okay. Now, that's my picture. What do I want to know? I want to know the cosine. What's the cosine in that picture?
12/13.
Not too bad. Not too bad at all. All right, now we're gonna have the tangent of the angle whose sine is -4/5. Oops, there's a negative. So I won't draw it in quadrant 1, will I? I will tell you, this one's gonna be drawn in quadrant 4. So label your sides. Here's your angle. Label your sides. What's 4? What's 5? 5's the hypotenuse, +5, always on the hypotenuse. -4 is the opposite. Now, I'll call this A, call it B, I don't care what you call it. But when I do my Pythagorean theorem, no negatives. So A squared plus 4 squared equals 5 squared. Remember, you're squaring, so the negatives disappear, and it's easier just not to put them in. That way, no confusion. So I'm gonna put a 3 here. Now, like always, you have to be careful. Sometimes that 3 might be negative. If I were over here, that 3 would be negative, right? So pay attention to where you're putting that 3. It's positive in this case. Now, what do I want to know? What's the question want to know?
Tangent.
What's the tangent?
Negative
What's the
4/3.
tangent?
-4/3.
-4/3. Done. I think these are easy.
Yes.
They look hard, for sure. Is what? You're doing the next one? All right, so always start right here. This is where we start. Draw a picture of that. I don't think you'll get confused, because aren't we used to starting in the parentheses first? Yeah, order of operations. Okay, positive number, quadrant 1. Tangent 2/3. How does that look to everybody? Does that look about right? We're going to get a radical, no big deal. 3 squared plus 2 squared is c squared. This is c, hypotenuse is c. 9 plus 4, looks like I'm going to get the square root of 13. Don't let me go too fast. Is that okay with everybody? Just doing the Pythagorean theorem. All right, now what do I want to know? I want to know the cosine. All right, what's the cosine? 3 over root 13, which we know can't have the radical, so 3 root 13 over 13. This one has a radical in the problem. Please do not be alarmed. Just put it in your picture. So what does that mean? If the cosine is root 7 over 4, remember we're doing the inside parentheses part. So the cosine is root 7 over 4. Where does the root 7 go? Where does the 4 go? Root 7 is adjacent and 4 is hypotenuse. And then what do I have to do? Pythagorean theorem, so I'll call it A. So root 7 squared plus A squared equals 4 squared. Yes, do not, kids, this is so simple, don't let it confuse you. What happens when you square a square root? It's gone. So we end up with 7, plain 7. Plus a squared equals 16, so a squared equals 9, and it looks like a is going to equal 3. Now, what do I want to know about this picture? I want to know the sign. What's the sign?
3/4.
3/4. Easy. All right, one more. Try this one on your own, see what you come up with. Okay, did you draw a picture of a triangle? What quadrant did you draw it in? 1. Because we always draw it in 1, unless I tell you otherwise, right? All right, so then how did you label things? Hypotenuse was 4. Adjacent was 3. She said she got root 7 again. I think she's right. Did you all get root 7 for that?
Yeah. My answer was 4 root 7/7.
Okay, now be careful.
What does that mean?
What's tangent? Is this what your picture looked like?
Yes.
That picture's perfect. What's tangent?
Oh, okay, wait, I messed it up. I know
What is tangent?
that.
Opposite over adjacent. So I'm getting root 7/3. Is that what you got?
That's what I'm supposed to get.
Okay. I want you to get out your 4.7 homework then.
Oh, now we get out of I finally changed the back.
All right, and I want to do problem 1E and then problem 2. Because I want to show you how to do this on your calculator, you probably already know, but I want to do another one of these by hand. That would be 1E, and then we'll do problem number 2. Alrighty? So here we go. This is 1E on the 4.7 homework, so I hope you're working along with me so that you get it right and you don't have to do it again. Because who's the nicest teacher? Yeah. All right, so here we go. Draw a picture. Right there in quadrant 1, right? Something's going to be 1 and something's going to be 5. So what's what?
Adjacent's 1.
Adjacent is 1.
Hypotenuse 5.
Hypotenuse is 5. So then what do we do? Pythagorean theorem, we're going to find this guy over here. So 1 squared plus a squared is 5 squared. 1 plus a squared is 25. By the way, I said a here. It could be b. It does not matter. A and b doesn't matter. A squared equals 24. Whoops, this one's going to be a little trickier than before because the square root of 24 actually breaks down 2 radical 6. Because if you break down 24, It's 4 times 6, 2, 2, 2, 3. And we take out groups of 2, so out comes a 2, and in stays a 6. So this side is 2 root 6. Now, problem 1E, which is the one we're doing, wants the exact answer, no calculator. So what is the sign in this picture right here? 2 square root of 6 over 5, opposite over hypotenuse. So that is the answer to 1E. Okay? Now, just for fun, I want you to type this in on your calculator so I know what decimal it is. So type 2 square root 6 equals divided by 5. Did you get 0.9797958971?
Yep.
And believe it or not, it keeps going. Your calculator ran out of room, but that keeps going. That is not an exact answer. This is the exact answer. Okay, now let's type it in on our calculator, the problem, and see if we get that exact decimal right there. So to type it in on my calculator, do exactly what it says. Press sign. Did these parentheses automatically come up?
Yeah.
Yep. So then you press second cosine, and then 1 divided by 5. You got the same decimal, didn't you? So that's how we type it in on our calculator. We just type in exactly what the words are, numbers are. Easy. Okay? Again, exact answer. So if those directions say exact, that means that's the
Oh,
answer.
so is that 2?
Huh?
Is that 2 then?
Yeah.
Oh.
Okay. Now, let's see, we have time. Why don't we go through, maybe we can get this whole thing done. 1A.
Yep.
Wait, don't turn it in, because I think we're gonna get it all done, and we're just gonna get credit for it. So don't turn it in, check your work as we go through it, okay? If we don't get it done, you can turn it in, but I think we'll get it done.
Okay.
All right, here we go. Shh, I'm on 1A. You are gonna draw a picture of the triangle just exactly the way we've been doing all day here. Opposites root 3, hypotenuse is 2. With these numbers, you don't really need to do the Pythagorean theorem because you've memorized them. If that's a root 3 and that's a 2, this is gonna be a 1. If you did the Pythagorean theorem, you would get 1. But you don't need to go through that work because it's memorized. How big is that angle right there?
60.
The answer to the problem is 60 degrees. Here's a tricky one. This one is tricky. Okay, we just talked about this today. We did the same one? Ah, well, we'll do it again. This is a 0. And whenever a 0 is involved, you are not going to draw a triangle because no sides can be 0, right? That's not possible. So if we can't draw a triangle, we draw a circle. The important points on the circle are these: 0, 90, 180, 270, and these are the ordered pairs as you go around your circle. Tangent is y over x. I memorized my purple sheet. You're supposed to have it memorized. Tangent is y over x. So you simply go around your circle and you want y over x to be 0 over 1. So y is 0, x is 1. Well, as Jacob pointed out, we already did this problem. Isn't it right there? Y is 0, x is 1. So what angle is this? What label is this?
0
0. So the answer to that question is 0 degrees. If it had been up here, it would be 90 degrees. Those are the tricky ones, I think.
Maybe a really stupid question. But in what circumstance would that point be 360 since
Never.
0? Okay.
Never. We always want the smallest angle we can get. So while 360 is there, we would never say that would be 60.
Okay.
All right, this one, quadrant 2. Quadrant 2 for this one. I didn't put it on there. I promise I will on the test or quiz. All right, so my angle's in quadrant 2. Adjacent over hypotenuse. Now again, if you want to do the Pythagorean theorem, you can, but if that's a 1 and that's a 2, this is going to be a root 3. But you can always do the Pythagorean theorem. It's a right triangle. How big is this angle? 60. 60 is not the answer, because the answer has to be between, isn't this angle between 90 and 180? So you want to know how big this angle is right here, the one that gets you over to that line. So how big would that be? If that's 60, 120 degrees, very good. Because this is 180, and I stopped 60 before I got there. So 120, perfect. One more and we'll be done. Tangent. Negative root 3, I'm gonna put that over 1. I like that, over 1. This one will be in quadrant 4. The tangent, opposite, over adjacent, does that work for you? Hypotenuse is 2. How big's this angle right here?
60.
60, it's another 60. Watch it though, 60 is up here between 0 and 90. That is not where this is. This is down here. How big's that angle right there?
300.
Well, somebody could say 300 if you went all the way around this way,
Or negative 60.
but we always want the smallest one, so we're gonna say negative 60. Negative 60. All right? So, you do not need to turn in that assignment. Everybody that's here, if you're absent, too bad. And everybody that's here, I'm just gonna give you credit for that. Because